Hello. Today we're going to be talking about trigonometry of right triangles, and we're going to be calculating trigonometric functions at any angle, and we're going to be use right triangles to find the 6 trigonometric functions, use calculators to evaluate the 6 trigonometric functions of angles, and solve for missing sides in right triangles. And we're going to solve applied problems related to right triangles. So this first problem that I have labeled over here, they're asking us to find the side labeled x. So let's write that. So find, oops, doesn't work. So find the side labeled x. Okay. So how do we do this? So we know there's a different situation. When they tell you to find the 6 trigonometric functions and they give you an angle theta, they have to at least give you 2 sides. Now, why is that? Why do they have to give you 2 sides? It's because theta is a placeholder for any angle. Here, this example we have here, we can find all the other, angles and sides, because we know a triangle has 3 angles. This is one angle, this is another angle, this is another angle, and this, call this y side. So 3 sides, 3 angles. So really, if we wanted to, we can get everything here. We can get this angle, we can get y, but we need to do that. We're just solving for x. So how can we solve for x? So let's just get rid of these to get no confusion. Okay. So what do we have? So we have to remember our trigonometric ratios when we're solving something like this. So remember the acronym SOH-CAH-TOA, which is trigonometric functions are sine of theta equals the opposite, I'm going to call it O, over hypotenuse, which we know the opposite is the opposite of theta, in this case 60%. The hypotenuse is always the longest side, if you learn geometry, or it's the opposite of the right angle. And then the adjacent is, it's not the hypotenuse and it's not the opposite, so it's just whatever's left. Or you can just think of it as like being close to the angle if you see it right here. But it doesn't really matter. You can just think it out, use logic. So what can we use here? Do we use sine of theta? Do we use cosine of theta, which is adjacent over hypotenuse, or do we use tangent of theta equals opposite over adjacent? So what do we have? So we have our hypotenuse, which is 18, and we have our adjacent angle, which is x. Okay. So that's what we're solving for. So let's go out of our way and use tangent. Now we're going to replace theta with 60 degrees because we have it here. So we're going to write tangent of 60 degrees equals our, oh, that's wrong. Sorry about that. I meant to use cosine. Why is my, yeah. We need to use cosine. Sorry. So cosine of 60 degrees equals our adjacent, which is x, divided by hypotenuse, which is 18. So now we can rearrange with algebra. You can either divide by 18 or you can do a cross multiply, which I like to do. So you get x equals cosine of 60. Usually when you have things like this, you need to use a calculator, but we know what cosine of 60 is. So if we go back to the unit circle, pi over 6, we have over here, we have pi over 4, and we have pi over 3. Well, if we raise angles, this is 30, 45, and then this is 60. Well, we know that cosine of pi over 3 is 1/2. This is the terminal points. This is the x and y of pi over 3, or 60 degrees. So you should, if you're working in the unit circle, or if it's something that we know the angle of, we can use it. So at this point, we know that cosine of 60 degrees is 1/2. So we can Okay, so now this is problem 2. This is the triangle that they gave us. And once again, our objective is to solve for x. So now, first thing I like to do when I'm doing this problem is identify what we have. We have an angle, and we have, well, along this angle, we have our opposite of this angle. We don't have our hypotenuse, which we don't need, and we have our adjacent. So right away, I know to use tangent, TOA. Our whole point is to solve for side x, so we do tangent of 42 degrees equals opposite x divided by 11. Now from here, it's just algebra. So if I times 11 on here, x equals tangent of 42, which I don't know, so we have to use a calculator, times 11. And make sure when you're doing any sort of triangles, don't make a dumb mistake and be in radians, because you're in degrees, so it'd be very stupid to be in radians. So make sure you're in degrees. So tangent of 42 times 11 x